Okay, this is the Atoms and Electrons past paper questions, section 1. This is the second video I've done on Atoms and Electrons past paper questions. So, I have some percentage abundances of europium, and you have to find the relative isotopic mass and define the term relative isotopic mass. So, relative atomic mass. And I'll give you 5 seconds to pause the video and have a go at the question. Come back when you have done the answer. Okay, we'll just delete this box. So the relative isotopic mass is the mass of an atom isotope when compared to the mass of 1/12 of an atom, or 12. And for the calculation, we just need to do 47.77 over 100 times 151. First isotope, done. Then you add 52.23 over 100 times 153. And then that equals 152.0446. To do it to 2 decimal places, so it's 152.04. Done. Now what to do. Question number 2. In terms of protons, neutrons, and electrons, how is an atom of 151 europium different from an atom of 153 europium? And how is an atom of 151 europium similar to an atom of 153 europium? 2 minutes, go. Okay, just delete the boxes again. 153 europium has more neutrons than 151 europium, as isotopes have more neutrons than their the normal standard isotopes of an atom, and isotopes have the same number of protons and the same number of electrons, otherwise they would not be isotopes. So, number 3. Modern plasma television screens emit light when mixtures of noble gases such as neon and xenon are ionized. The first ionization energies of neon and xenon are shown in the table below. Positive 2081 kilojoules per mole and positive 1170 kilojoules per mole. So, give you about 4 minutes to answer the question, and it's 3 marks, so we have 3 points to think about. Okay, delete the box again. As you go down the group, nuclear charge increases, atomic radii increases, and electron shielding also increases. Electron shielding a distance from the nucleus overcome the greater nuclear charge. So, if you look on the periodic table, neon and xenon are in the same period. So, if you say as you go down the group, you are instantly telling the examiner you are going downwards like this, all the way down to xenon, and you're talking about it down the group. So you get a mark saying the nuclear charge increases, another mark was saying that atomic radii and electron shielding increasing, and this phrase, electron shielding and distance from the nucleus overcome the greater nuclear charge, is that key phrase that you need to get the third mark rather. So we'll move on to the next part. So this diagram is showing you different ionization energies of elements. So you need to define the term first ionization energy. I need to explain why the first ionized energy show a general increase across period 2, lithium to neon, so it's from atomic number 3 to atomic number 10 on that graph. And I'll give you 7 minutes to do the questions. Pause the video and have a go. Okay. Delete the boxes. 2. So, first ionization energy is the energy required to remove 1 electron from 1 mole of gaseous atoms to form 1 plus gaseous ions. Boom, done. Nothing else said. Nuclear attraction increases and similar electron shielding. There's 2 things you need to say in order to show what the general increase and why. So for question number 5, we have the first ionization energy of oxygen is 1314 kilojoules per mole. and the second ionization energy of oxygen is 3,388 kilojoules per mole. So we need to write an equation to represent the second ionization energy of oxygen, and we need to include state symbols, something I never ever do, because state symbols are annoying and you always forget them. So give you 2 minutes to answer the questions. Okay. Delete the boxes. So the equation you should have is oxygen plus gaseous goes to oxygen 2 plus gaseous plus E minus. That's what we need to write, although you would have a subscript for the pluses. I can't do it because I'm on a computer and they don't like subscripts very much. So the next part is greater nuclear attraction of remaining electrons and a decreased atomic radii. That's what we need to say about the second ionization energy of oxygen having a greater value than the first ionization energy of oxygen. So decreased atomic radii because the one electron has just been removed from each atom, so the nucleus is going to attract the number of electrons that are actually there and decrease the atomic radii, and greater nuclear attraction just because there are fewer electrons than there were before. So for question number 6, we need to state what is meant by the term atomic number, complete the full electron configuration for a titanium atom, and identify the seventh element in the fourth period. And we need to state what block the element is in as well. Okay, for the atomic number term, it is the number of protons in an atom. And for the substellar notation for the electronic configuration, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d2. Seventh element in the fourth period is manganese, and it's in block D, the transition elements. So moving on to the next question now, number 7. So the group 2 element magnesium was first isolated by Sir Humphrey Davy in 1808, and magnesium has 3 stable isotopes, 24 Mg, 25 and 26 Mg. So you need to use the percentage of abundances and the molecular masses in order to calculate the relative atomic mass, and you need to define the term relative atomic mass. 7 marks, so I'll give you 9 minutes. And go. Okay, hopefully you had a go at that question. So yeah, 24 Mg has 12 protons, 12 electrons and 12 neutrons. Same again for the magnesium atom, except it has 13 neutrons rather than 12. So calculating the relative atomic mass, we get 24.33 times 24 and like that. So that's how you get to that answer, and the term relative atomic mass is the weighted mean mass of an atom when compared to 1/12 of the mass of an atom of carbon-12. And for question 8 and 9, since they're two relatively short questions, I'll let you do them both together. So the group 7 element bromine was discovered by Ballard in 1826. Bromine gets its name from the Greek bromos, meaning stench. So what's meant by the term isotopes? Complete the table below to show the atomic structures of the bromine isotopes and write the full electron configuration of the bromine atom. Same thing again with antimony. It has 2 main isotopes, and what's meant by the term isotopes, and you need to complete the table to show the properties of the particles that make up isotopes. So off we go. Okay, hopefully you had a go at those questions, so I'll just delete the boxes, because the isotopes terms are exactly the same. Atoms with the same number of protons and electrons but a different number of neutrons. So if you got those both right, it's a mark. Way, 2 marks for the win. So if we look at the table, 35, 44 and 35, 44 and 35 for a standard bromine atom, 35, 46 and 35 electrons for 81 bromine. And the full configuration is 1s2, 2s2, 2p6, 3s2, 3s2, 3p6, 4s2, 3d10 and 4p5. And for the table, 1 plus 1 for a proton, 1 0 for a neutron, 1 over 2000 for an electron, and minus 1 for the charge. So moving on to the next page, this is the question 10 and 11. So same job here. What do you understand by the relative atomic mass? And calculated the relative atomic mass of antimony, and what is meant by the term isotopes for question 11, and completing this table to the titanium isotopes, and doing the same thing again, calculating relative atomic mass of the samples of titanium. So give you 5 seconds to pause and have a go. Okay, so starting from the top, the weighted mean mass of an atom when compared to 1/12 of the mass of an atom of carbon-12 is the definition for this one and this one. And calculating the relative atomic mass, we get 57.21 over 100 times 121 plus 42.79 over 100 times 123 gives us 121.9. 2 3 significant figures. Three significant figures is 1, 2, 2 actually, but I like to have at least one decimal place in my answers. Next is the proton numbers for titanium. No Leander estimates, please. Protons and electrons are 23, and neutrons are 23 and 24. So we do the same thing again. 46 times 8.9 over 100. 47 times 9.8 over 100, and 81.3 over 100 times 48 is equals 47.724, which to 3 significant figures is 47.7. So I hope you found this past paper question video useful. If not, give us a comment down below and tell me what kind of questions you do want to see. Thank you for watching, and goodbye.